Hello students. For your second assignment, I want you to create a bubble sort program. Now again, you can find bubble sort anywhere on the internet, but I want you to think about it. I want you to go through it and write it yourself. Come up with how you would do a bubble sort. So let's look at the assignment. Again, you create a bubble sort method called BUBBLE capital SRT. And this method will sort the array passed to it as a parameter and will display the results of every pass through the bubble sort. What I want to do is, as every pass goes through, I want you to see how the larger numbers are getting, to the right side of the array. And I'll show it to you. I have a kind of a screenshot here of what the bubble sort should look like when you're completed. You'll have different numbers because I randomly put the numbers into it, but as you can see, 82 being the largest number appears on the right, and slowly the 2 comes up to the left. I also put 2 commands in there. We'll talk about in a little bit how you can measure how long it takes. You start before you enter the bubble sort method, and you get the time when you enter the bubble sort method, and you get the time when you exit the bubble sort method. And the time is actually in nanoseconds. So if I look at this, this is about 1.8 seconds it's going to take to do the bubble sort. So let's continue on. When you look at the results show the bubble sort working with the sorting of the highest values appearing on the right first, and then working on down towards the left. Again, the main method is given above. You're to use the main method as it is. Don't make any modifications to it. Within the main method, you should see 2 instructions, and this is the instructions I was talking about. And I have long start equals system.nanotime, long end equals system.nanotime. These instructions get system time in nanoseconds. The time is obtained before the bubble sort method is called and after the bubble sort method returns. The time it took for the bubble sort to execute is then displayed in nanoseconds on the screen. If you run the program multiple times, you'll see a slight variance in the time that the method takes to execute. And it's also going to take a little longer because we are displaying every pass through it on the screen. But just kind of give you an idea, in the future, if you want to time some of your sorting methods, things like that, you can use system.nanotime. Again, you can find bubble sort programs on the internet, but I'd like you to attempt this program on your own so you earn the full measure of the sorting algorithm. It's worth 40 points and it's due by the end of the day on February 4th, 2023. Here's the main method. And so if you look at it, here's main. And what we're doing is we're going to create this time an object. So I want the bubble sort method actually to be in a separate class, and we're going to call it the bubble sort class. And so I created a bubble sort object, BSRT. We're going to make an array size, and it's going to be 16 elements. And the array is going to be called ARR, and they're going to be integers, 16 elements. And so again, we'll go from, I'll have a little index here, j equals 0 to j less than 16. J++, so we're going to fill the array with random numbers. So integer n equals java.language.math random times 99. So anywhere from 0 to 99, you're going to get a random number put into n. And ARRJ, the element starting at 0, is going to get that random number. So what we're going to do is create an array of random numbers. First thing we want to do is we're going to print out the array. So we're going to print out the array, all 16 elements from index 0 to 15, and they're all being one line so you can see what it starts with. Then we'll call system.nano.time method to get the start time of the bubble sort. We'll call the bubble sort with the array, so it sorts the array, and then we will get the time when it comes back from the bubble sort method, and we'll just say the time required to do sort was, and we'll take the start time, or take the end time and subtract off the start time, and just stick nanoseconds after it. So if we run this, let's just bring up the program itself. Here's our main method I was talking about. And so if we run, like I said, your numbers are going to be a little different. Oh, that's interesting. I have 2 2s, it looks like, in there. Yeah, I do. There's a 2 and a 2. So anyway, it worked. And 2 97s. That was interesting. But as you can see, it took a while for the 2 to come. And actually, it looks like the bubble sort might have been done right around here somewhere. It looks like all the numbers are in the right order. So we didn't have to continue as much as we did. And there's another one. Okay, this is a good one. And here's 92. It gets over to here. That's the first one. And then as we go down. Actually, 16 was first over here. So 92 bubbled up over here. Then 80, then 79, so on and so forth. Till finally we got 10 around here and everything. I know 16 was out of place. So 16's in place here. So this looks like we had one extra we didn't have to do. And this took about 2.9 seconds to do. So that's what I want you to get when you're done with your assignment. Any questions, just email me. And that's it for this week. Hopefully everything's going well. Any problems, anything you have questions on not only the homework but anything in the class, drop me an email at menzlr@matc.edu. Okay, have a good week. Bye.